get going. Moving along in the world of vectors. So, start off with this. Operations with vectors. Like, what can you do with one vector and another vector? For example, two trees leaning on each other. What's the resulting vector of those two vectors? So that's the sort of idea we have going on here in a very basic way. Now, show that the vectors are as. Remember, it matters that you start here. And PQ, it matters that you start there. There's our x1, y1, x1, y1. Show that they are equivalent. Well, it means they have the same direction, which you can kind of look at it, and they have the same magnitude. You're kind of like, yeah, I think they're equivalent. Now, they want you to do a little more than that. So, what they're saying is, use the component form, and let's move both of these originating points to the origin and see if they're the exact same vector. So x2, x1, we're going to focus on rs. So this is my x1, y1. This has to be my x2, y2 for rs. So I'm going to plug things in where they belong. So -1 minus -4. And then y2 would be 6 minus 2. And let's keep going. That would be -1 plus 4, which is 3. 6 minus 2 is 4. So, PQ. Well, P, x1, y1, Q, x2, y2. Let's do the same exercise. So 5 minus x sub 2, x sub 1, x sub 2 minus x sub 1. Y sub 2 minus y sub 1. And if we clean that up, it'd be 3, 4. Same thing, but let's get a visual image. So it's 1, 2, 3, 1, 2, 3, 4. Both of them, if moved, would look just like that. So they are for sure equivalent. All right. There's your little warm-up. All right, so here we go. Adding, subtracting vectors, and I suppose we should add multiplication because you can see we're multiplying a vector by -2, and we're multiplying a vector by 1/4. Well, let's get started. This is as simple as it gets. So it's -2 times that vector, and you would get 12, -8. So they're going to ask you to give a visual image of what's going on. So 12, -8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 8 would be down here somewhere. And so notice it completely changes the direction. That's what this did. And it doubled the magnitude. So essentially that's what's going on. Let's go to this one. 1/4 of m. Well, that'd be like just multiplying 1/4 times m. So that would be 2/4 or 1/2 -3/4. Now, it's going to be a little difficult to draw because it's so small, but now we're talking about letter B. The original was 2, -3. Now it's 1/2, so we go barely out and down 3/4, which would be right about here. So it just shrunk it, just lost 1/4 of its power. That's all you're really showing. Same direction. What happens if we add vectors together? I always think of two trees leaning. I've already said that. What's the resulting unit of force, okay? So Z, so we add these together and we get -4 and then 1. Letter C. So here's a tree leaning that way, a force pulling that way. What's the resulting force? -4, 1. 1, 2, 3, 4, 1, which makes sense. This is subtracting power from that, but this is kind of pulling that vector up towards itself because it's longer and stronger. Now we're going to subtract. Well, subtract means guess what? Subtract. So m, get rid of that 1/4. 2 minus a -6 would be 8, and then -3 minus 4 would be -7. So letter D, again I've got vector Z, vector M, we're subtracting. M is subtracting the power of Z. So that result in 8, 2, 3, 4, 5, 6, 7, 8. That's 4, 5, 6, 7. And so that's the resulting vector picture, okay? If you took away that power from that vector, you would result in a vector in that area. So the world of physics is upon us. All right, grand finale, special unit vectors. So how do we know that they're unit vectors? Well, if we actually thought about it, I'm going to make this unit 1 way out here. So there's 1. That just means it's a unit vector. It's a vector, length 1, magnitude 1, and it's in component form. That means it originates from the origin. What about 0, 1? Well, that would be that way, because that's 0, 1, and it's in component form. That's what these little guys are telling you. Now, what's interesting is, after you've dealt with 10 million of these, you'll realize these I's and J's are not that valuable. I hate to say that, but what is this? Well, it's like 4 times the unit vector I, which is 1, 0, plus 3 times the unit vector j, 0, 1, and if we just distribute, we get 4, 0, plus, 0, 3. If we add that together, 4 plus 0 is 4, 0 plus 3 is 3, and we think, well, wait a minute, couldn't you just have taken that off, put it first, take that off, put it second? Yes. So after you've done a few of these, you realize I and j are not that significant. So there's my vector in component form, which means I got to go 4 to the right, 3 up. There's my vector. And I go, hey, that's a 3, 4, 5. So I just found the magnitude just using the good old families or Pythagorean triples. But if you didn't know that, you can go a squared plus b squared equals c squared. What's the direction angle? Well, on this one, it's pretty clear. It's going to be up, whatever theta is. I kind of just like tangent. So 3/4. And here we go. So I got to go second tangent. Second tangent. I'm just going to go 0.75. And that's 36 I'll just say 87. So I took second tangent and it spit out 36.87 degrees. And yeah, it looks proper, okay? So that's a good warm-up for you. I think you guys are ready for your assignment. I don't think this lesson was too bad.